In this mini clip, we will be discussing ratio and proportion. Our question reads, 30 milliliters of 0.8 molar HCl are added to 2 liters of water. How many milliliters of 0.8 molar HCl must be added to 5 liters of water to maintain the same final concentration? Before we begin, let's just highlight the key points. We're first told that we have 30 milliliters of 0.8 molar HCl that's added to 2 liters of water. Next, we're asked to find how many milliliters of 0.8 molar HCl that must be added to 5 liters of water. And lastly, it's very important that they have the same final concentration. Now looking back at our first piece of information, we have for 30 milliliters of 0.8 molar HCl, we have 2 liters of water. This is known as a ratio, and ratios can be represented in fraction form. However, you need to be very careful with being consistent in what is in the numerator and what is in the denominator. So for my ratio, my numerator will be volume of HCl. Volume HCl. And the volume of HCl is measured in milliliters. So I'm going to put that in brackets. The denominator of my ratio will be volume of water. So volume, and I'm going to put H2O for water. Now the volume for water is measured in liters. You might be wondering why we have different units. As long as we are consistent in having the volume of HCl in milliliters and the volume of water in liters, we can have these different units. But we need to ensure whenever we deal with the volume of water, it's in liters, and the volume of our acid is in milliliters. Now I'm going to replace this ratio with our numerical values for our numerator and denominator. So in our first ratio, we have 30 milliliters of HCl. So this is our volume of our acid. So we have 30 as our numerator, and in our denominator, we have 2 liters of water. So I'm just going to write a 2. This is our first ratio. In our second ratio, we don't know how many milliliters of HCl we need. So our numerator is unknown, which I will denote by writing an X. Our denominator, however, will be 5, since there are 5 liters of water. Now, because we have the same molar concentration of our acid, 0.8 and 0.8 in our second ratio, in order to maintain the same final concentration, we need to have these two ratios equal to each other. Because obviously if this one has more water, it's going to need more volume of HCl in order to have the same final concentration as our first solution. All we're left to do now is to isolate for our X. We can first divide 30 by 2 on this side. 30 divided by 2 will give us 15. So 15 is equal to X over 5. Isolating for our X, we need to get rid of this 5. Since the operation here is division, we need to multiply both sides by 5, since the multiplication is the opposite operation of division. So these parentheses mean I'm multiplying. So X over 5 times 5, but we also need to do this on the other side of the equation. Five times 15 will give us 75. is equal to, now we have these 5 divide out to 1, and we're left with x. So our x represented our volume of HCl in milliliters. So for our concluding statement, we will have, therefore, 75 milliliters, don't forget your units, of 0.8 molar HCl must be added. And this is how you would solve this problem.